Okay, this lesson is on solving systems of inequalities. Currently it's on lab manual page 53. That could change, but just look at the table of contents. So when you're solving linear systems of inequalities, I think it's best to first rewrite the linear inequality in slope-intercept form. And just to remind you, slope-intercept form is y equals mx plus b. And of course there'd be an inequality here. But this is slope-intercept form. So when y is by itself without a number in the front, then you are able to see what the slope of the line is. And remember, the m is the slope, okay? And remember, when you're graphing, the slope can be calculated by the rise over the run, because we know that slope is the change in the y's, the vertical change, over the change in the x's, or the horizontal change. So vertical rise over run. All right, so that is your slope of your line, and this b here is the y-intercept, and that's a point. So the y-intercept is 0, b, the coordinate 0, which means you move left or right 0, and then you move up or down, depending if that's a negative or a positive. And so this slope, this rise over run, I call it a movement. It's a change. It's a movement, and this is a point. And so when you're graphing, you start here first. You graph the y-intercept first, and then you start counting rise over run to get your next point and your next point, and we're going to go over that. All right, so notice that I wrote y equals mx plus b here. It's because when you're graphing inequalities, which this is what an inequality looks like, a system of inequalities, and when you're graphing these inequalities, the first thing you want to do is you want to graph the boundary line. So if you've got less than or equal to, or greater than or equal to, or less than or equal to, then the boundary line is this, y equals mx plus b, and if it's less than or equal to or greater than or equal to, then the line that you draw will be a solid line, because you get to include the points on the line that equal to. And if it's less than or greater than, then the line's going to be dashed, because you don't get to include the points on the boundary line. Now, if the inequality is in slope-intercept form, okay, in other words, when y is by itself, this is why I like to do this, then if it's y is greater than or y is greater than or equal to, you're going to shade above the line that you draw, the boundary line. And if it's y is less than or equal to, you're going to be shading below the line. So we'll go over that. And then the final thing before we get to our examples is, when you're asked to solve systems of inequalities, it's not possible to write the solutions in any kind of format. The solution is the intersection of the two shaded regions. So the solution will be the picture of the graph, because there's going to be an infinite amount of points in that intersection. So let me go through all of this, and then this will make sense. All right, so here's our first one. They're already in slope-intercept form, so we could just deal with the graphing. And so what you're going to do is graph the boundary line of each of these. And after you get good at this is not necessary to write down, but I'm going to show all my work. So the boundary line for y is less than or equal to negative x minus 2 is y equals, and I went ahead and put my understood 1 in there, negative 1 over 1, x minus 2. So remember, to graph, the first thing you're going to do is graph the y-intercept. So the y-intercept is negative 2, and so that's the point 0, negative 2. So you put a point on 0, negative 2. And then you want to graph the movement. And so this movement, rise over run, a negative 1 over a positive 1, you only can give the negative to either the numerator or the denominator. So a negative 1 on the top means you're going to go down 1, and a positive 1 on the bottom means you're going to go right 1. And we can do that over and over again. Down 1, right 1, put a point. Down 1, right 1, put a point. Down 1, right 1, put a point. Or, 1 over a negative 1 is the same number. So you could also go up 1 and left 1, put a point. Up 1 and left 1, put a point. Up 1 and left 1, put a point. Up 1 and left 1. So that's our boundary line. Okay. And then you go back to the inequality and it says less than or equal to. So that means it's going to be a solid line because you get to include the points. This is where it equals, y equals. So you have a solid line. And then now the last thing is for this one is it's less than. And I like when y is by itself because I can read this. So here's your y-axis, right? Here's your x-axis. So if your y's have to be less than this line, that's why we're going to shade below. So you shade the down arrow when it's less than. So you don't have to do test points. Now, some teachers teach test points, and you can. But because I've gone ahead and it's already in slope-intercept form, I know that the y's are less than this line when it's below the line. All right, so that's the first one. Now the second one is y is less than negative 5x plus 2. So the boundary line would be y equals negative 5 over 1x plus 2. So again, you're going to graph the y-intercept first. So that's up to 0, 2. And then you're going to graph the movement, rise over run, negative 5 over 1. So negative 5 means instead of going up 5, you're going to go down 5. 1, 2, 3, 4, 5. And then the 1 is positive, so you're going to go right 1. And you can do that as many times as you need to. Down 5, 1, 2, 3, 4, 5 over 1. And you can see I ran out of room, so this is why it's helpful to understand that this is also the same as 5 over negative 1. So I could go up 5 from my y-intercept, and I messed up. Let's try that again. I went to the wrong y-intercept. Here's our y-intercept. So again, I'm going to go down 5, right 1, 1, 2, 3, 4, 5 over 1, down 5, 1, 2, 3, 4, 5 over 1. Or I can go up 5, 1, 2, 3, 4, 5, left 1. And now this is a less than, so it's going to be a dashed line like that. And then it's less than, so same thing. Y is less than, so you wouldn't shade above this line. Now, don't shade the up arrow. You're going to shade the down arrow. You're going to shade below this line. And I know it's tempting to say left and right, but it's always above the line or below the line. So I like to look at the arrows to help me remember. If it's less than, you're shading that down arrow. Now, the final thing we want to do is we make it very clear what our solution is. So the solution is the intersection between these two shadings, and that's right here. So I'm going to color that in just a little darker. So that is our solution. Not here and not here. So we want to make it very clear that we have found the intersection. And that's it. That is your answer. The picture of this graph is your solution. There's an infinite amount of points in here. Okay. Now the next one I put in here so that we could make sure we understood this. What does x over 5 mean? It's a common question I get in my calculus class, so we'll take care of it here. There's an understood 1 right here. And 1x over 5 really just means 1 times x over 5, which really just means 1/5 times x minus 3. So that x over 5, you have to know that that slope is 1/5. Okay, x over 5 and 1/5 x means the same thing. Because if you multiply together these two, x over 1 times 1 over 5, you get 1x over 5 times 1 is 5. So that's a common question. All right, now to graph that, the y-intercept is -3, so you put a point on -3. And the slope is 1/5, so that means you're going to go up 1 and then over to the right 5. 1, 2, 3, 4, 5. Put a point. Up 1 and then 1, 2, 3, 4, 5. Put a point. And it also means you could go down 1 and left 5 because a -1 over a -5 is the same thing. So down 1, left 5, 1, 2, 3, 4, 5. Down 1, left 5, 1, 2, 3, 4, 5. Then that's your boundary line. You want to decide if it's shaded, solid or dash. So it's dash since it's just greater than. And then you want to decide where you shade. And so it's y is greater than. So you're going to shade above the line or the up arrow. So this is our shading here. All right, halfway done with this one. All right, now I added this because I thought that maybe we might have a question on this. So for the first time, the y is not on the left side. So with my shading technique, what I want to do is I want to convert this. So y is already by itself, so all I need to do is put it on the left. And so you just want to maintain the inequality. So right now, x is greater than or equal to y means that the x's are bigger than the y's, and the open part of this inequality is toward the x. So when I shift it around, I need to make sure I maintain that relationship. So when I put y on the left, that inequality is going to switch so that x is still greater than y. Okay, so now the boundary line would be y equals 1 over 1x plus 0, if you want to put it in y equals mx plus b form. Okay, so my y-intercept is 0, and I'm going to change colors because I made a mistake last time, and I don't want to make any more mistakes. So I'll put a point on the 0, and then my slope is up 1 over 1, up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1, down 1, left 1. And then I'm going to notice that it's less than or equal to, so that's a solid line. Okay. And now, don't look at this, look at that shading there. Y is less than means I'm going to shade below the line, and that's this. And then the last step is to shade a little bit more clearly what the intersection of those two lines are. And that intersection occurs right here. And then you can check your work and make sure you got a dashed line and a solid line, and one is greater than and one is less than. So that is your answer. There's no way to write that another way. And this goes on forever and ever and ever and ever this way in this little sliver. All right, let's move on to the next one. All right, so here for the first time, again, I've got 4x plus y is less than 2. This is not in slope-intercept form. So what I want to do is move this term over to the other side. And we're still sort of early in the class, so what I'll do is I'll show you that the work, you would subtract 4x from both sides, so that when you add the left side, you get 4x minus 4x. They cancel, that's 0. And then you have over here, y is less than, and these are not like terms, so that's just a negative 4x plus 2. Okay, so here's what the shortcut is. There are 3 terms, 4x, y, and 2. If you want to move terms, you don't do it by division, you just use addition and subtraction. So the shortcut is you can take this 4x and just move it over and over to the other side, and when you do, it changes its sign. That's all that happens. So if it was a positive 4x on the left, when you move it to the right, it's going to become a negative 4x. Okay, so that our boundary line is, and I'm about ready to stop writing down our boundary line because we know it's the same thing. It's just that's equal to. And I'm going to graph the y-intercept first, so that would be 0, 2. And then the slope would be negative 4 over positive 1, which means down 4, 1, 2, 3, 4, and right 1. Or it could mean up 4, 1, 2, 3, 4, and left 1. And I haven't mentioned it yet. Whenever your slope is negative, you're going to have a line that's decreasing as you go left to right. So you can check your work to make sure you didn't forget to count a negative movement. So this one has a negative slope and you have a decreasing line. So up 4 left one or down 4 right one's going to give you that negative slope. All right, and then if we shade less than, that means we're going to shade below the line. All right, now the next thing is this y is greater than -2, so its boundary line would be y equals -2. And this is the first time we've had one of these. And this, you have to memorize it. This is going to give you, this is the equation of a horizontal line. All right, and it's really good to memorize. When it's y equals a constant, it's a horizontal line. And the reason is because here's your y-axis, and y equals -2 will go down to y equals -2. And y is going to stay -2 no matter what x is. So when x is 1, y is -2. When x is 2, y is -2. When x is 3, y is -2. Or you could think of it this way. Y equals 0x minus 2 gives you a slope of 0 over 1, which is up 0 and over 1. Up 0 over 1. Anyway, okay, so then you look at this. That's a greater than, so it's dashed line. Like that. And then you're going to shade above because its y is greater than. So that would be all of this. And this time I'm just going to do the intersection. So when it's greater than, and then this is already shaded, this is your solution right here, this area here. And what we're saying with these dashed lines is that the points on these lines would give you a false statement, but the points in this shaded region would give you a true statement. That's what it means to solve. It means to state everything that gives you a true statement. And this can't be written any other way than just this picture. All right, so example 4, we have got, for the first time, 3 inequalities. And yes, you can have as many as you want. So I've given you 3 here, and this one is not in slope-intercept form. So the way I like to do it, I like to put it in slope-intercept form. So the first thing we want to do, like we did over here, we want to move this 3x term over, and when we do, it's going to change sign. So that's going to be 2y is greater than or equal to -3x plus 6. All right, the next thing we're going to do is we're going to get rid of this 2 that's being multiplied to the y. And so we're going to divide by 2. And whatever you do on one side, you do on the other. So I'll just show my work here. Now, if I were dividing by a negative number at this point, I would switch the signs. But it's not negative, so I'm just going to cancel that. And then I need to remember that this 2, this whole side is being divided by 2, so you have to distribute that to each of these. So that would be -3x divided by 2, which is -3/2 x. And this would be 6 divided by 2, which is +3. Okay, so now I can graph that. Y-intercept is 3, 1, 2, 3. And the slope is -3 over 2, so that's down 3, 1, 2, 3, and over to the right 2, 1, 2. It's a negative slope, so you should have a falling line. Or you could go up 3 and left 2. All right, it's a equal to, so that's going to be a solid 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. The more points you put, the less you have to use a ruler. So that's why, another reason why I like slope-intercept form. Okay. Now at this point, I'm going to not shade because it's going to get more complicated the more graphs you have. So I'm going to shade all at once, and I'll take you through that. And the other thing I wanted you to know is that once you get really good, you may remember another way to graph, and that is with x and y intercepts. So the x-intercept is when you put 0 in for y. So if you use the cover-up method, you see 3x equals 6. You can see that x-intercept is 2. And if you want to use the y-intercept, cover up the x, and that would be a y-intercept of 3, and there's your line. But I like slope because then I can put extra points. But you could do that, and then you have to make sure that if this is a positive, you can read that as a greater than. But if it's a negative, it gets a little tricky. All right, next one, x is greater than 3. The boundary line is x equal 3, and so this is a companion to this. A y equals a constant is a horizontal line. Well, an x equals a constant is going to be a vertical line. So x equals 3, and it's greater than, is going to be a dashed line through x equals 3. All right, and we'll shade in a minute. And then y is less than or equal to 2 would be a point on the 2 on the y-axis, and then that horizontal line like that. All right, now I said I was going to shade mentally. So let's go back. So our pencil line is this one, and it's greater than, right? So that would be shading above. I'm not going to not shade. I'm going to actually shade instead of doing it mentally for this first one. And then x is greater than 3. Here's our x is greater than 3 right here. And so that is an exception to the rule since it's not even going through the y-axis. That would mean right of x. X, the numbers that are greater than 3, the x coordinates that are greater than 3 would be 4 and 5 and 6 and 7 and 8. So you would shade to the right. Okay, so that's over here. All right, and then the last one, y is less than or equal to, that's shading below. And it gets a little complicated. So when you shade above and to the right, that's right here, and then below, that's right here. So you get this little area that goes on forever and ever. Right there. And you just want to be very clear because this is you telling me the solutions, stating very clearly where the intersection occurs, like that. So that's a system of 3 inequalities. All right. And so here is one with a lot of work, and I'm going to suggest that you pause the video and try it, but I just want you to realize right here that you have a negative y. So when you divide by a negative number, remember to switch the signs. So pause it and try this one. But I'm going to keep going. All right, so the first one is already in good shape. The second one, you might want to put a negative 1 there. So that would be negative 1y is greater than, move that negative 2x to the right, and it becomes positive 2x, and that 3 is plus 3. All right, now you have to divide by negative 1, and when you divide an inequality by a negative, then that sign has to switch. So that's y is less than negative 2x minus 3. So that's your second equation. All right, the third one, 5x minus 2y is less than or equal to 6. The first step would be to move that positive 5x over to the other side so that sign doesn't switch when you move terms. So that's still less than or equal to negative 5x plus 6. And then we have to divide every term by negative 2. All right, so when you divide by negative 2, you've got to switch that sign. And then negative 5 divided by negative 2 is positive 5 halves x. And 6 divided by negative 2 is negative 3. So did you get that? So if you divide both sides by negative 2, distribute that negative 2 to both terms there, that sign switches because you divided by a negative. A negative divided by a negative is positive 5 halves x. And a positive 6 divided by 2 is negative 3. So now we have all of our equations in slope-intercept form so that we can do some shading. All right, so remember to graph. You're going to graph the y-intercept first. So doing this first one, you go up to 0, 2, put the point down, and then your slope is 1/2, so you're going to go up 1 and over to the right 2, up 1, right 2, up 1, right 2, up 1, right 2, or you could go down 1, left 2, down 1, left 2, down 1, left 2. Positive slope, increasing line. It's an equal to, so it's going to be a solid line, And now I'm going to mentally do it. This is going to be a shade below. All right. Second one, slope-intercept form right here. The y-intercept is -3, so 1, 2, 3. The slope is -2 over +1, so down to right 1, down to right 1, down to right 1, or up to left 1, up to left 1, up to left 1. It's just a less than, so it's a dashed line. Okay, and less than is going to be down here. Okay, we'll come back and do the shading in a minute. And then this last one, y is greater than or equal to 5/2 x minus 3. So that's 1, 2, 3. Y-intercept again on -3. Slope is +5/2, up 5, 1, 2, 3, 4, 5, right 2, up 5, 1, 2, 3, 4, 5, right 2. All right. And then down 5, 1, 2, 3, 4, 5, left 2. All right, and then it's greater than or equal to, so that's a solid line. There's a lot to keep up with, so try to be methodical. All right, now watch the shading. Mentally, I'm going to shade. So the first one is this pencil. It's less than, so that's down here. And the second one is less than, so that gives us this area here, right there. And then the last one is greater than, so that gives us this one. All right, so if that's too much to keep up with, then do it, write it all down. So this one was that. This one, the second one was below. And the third one was greater than. And the only place where you have a solution is right here. So you do whatever you want to do. I like to graph my boundary lines first and then do my shading. And if you want to do each line and shade it at the, as you go, that's fine. It's just it makes it a little harder to see your y-intercepts. All right, the last one I put in here just to make sure you understand what this means. So this is a combined inequality, and x is greater than -5, but less than -3. Okay. So what that means is you're going to graph the boundary lines x equal -5 and x equal -3. And remember, those are vertical lines, so x equal -5, 1, 2, 3, 4, 5. X is equal to -5 all the time, while y can be anything, and it's an equal to, so that's a solid line. And x equal -3 would be a solid line through -3. And so x is between -5 and -3. Well, that's going to be right here. But you can understand it. This means x is greater than or equal to -5, and x is less than or equal to -3. So greater than -5 would be everything to the right of -5, and less than -3 would be everything to the left of -3. And the intersection is just this piece right here in between. So I'm not going to shade that right now, but I got the idea. All right, the next one, 5x minus 3y is greater than -6 would be -3y. Move that over. Don't change the sign yet. We're just moving terms, so that's going to stay greater than, and then -5x minus 6. Now I'm going to divide by -3, and that's going to give me y. Now I have to switch the sign. +5/3 x plus 2. All right, so that one I'll shade in. I'll do in red. So that's y-intercept 2, up 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3, or down 5, left 3. Okay, and I'm looking, and it's just a dashed line. And it's a less than, so I'm going to shade below. So mentally, I've got this idea right here. That's where it's going to be. And I have one more to go. Y is greater than or equal to -8. Remember, that's going to be a horizontal line through -8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And it's going to have a slope of 0, and it's a solid line. And I forgot to mention, when you graph a vertical line, x equals -5, that doesn't even have a slope. That's an undefined slope. So you really have to have that memorized. So that's a vertical line. It has that vertical line has no slope. It's an undefined slope. I think of it as, if you're talking about slope, a mountain, you could not ski down that vertical mountain. It would not go well for you. But you can ski across a horizontal surface. It's just kind of boring. So that's got a slope of 0, and that's got no slope. All right, back to this. So we know that we're shading in between these two vertical lines. We're shading below this red line, this one, and then you're shading above y equals -8. And so this is a fun one. This creates this little region right here. That's your solution. And that's a closed region. And this ends up being, if we wanted to do some word problems, these kinds of word problems would be called linear programming. And what you can do, there's all sorts of things. These are called constraints. And then it turns out that the endpoints of this region here are where the maximum and minimum values of certain functions are. And so we're not going to get into that, but that's a closed region. I like that. All right, to finish up, you can pause the video. I bet you can answer these questions. I don't use the test point method. I like to use the y equals mx plus b method and shade above or below the lines. But these questions sort of help you understand what solutions are, particular solutions are. So for 7, this is an infinite amount of points, but you can test these points to see whether they are solutions or not. So pause the video, do that, then come back. All right, so 7 says, which ordered pair is in the solution set of the system of inequalities shown in the accompanying graph? And then let's go backwards. Let's go ahead and write the system of equations that correspond to the graph below, and then check your answer to the first question algebraically. So this is called reciprocity. When you know something really well, you can go backwards and forwards. So first thing we want to do is test these points. So the point 0, 0 is right here, and that is not in the intersection of shading, so that's out. And the point 0, 1 means go right 0 and up 1. That's that point. That is not in the intersection, so that's out. And then the next point, 1, 5, means go right 1, up 5, and that's not in the intersection, so that's out. And then the last point, 3, 2, means go right 3 and up 2, and there's 3, 2, and that is in the intersection, so that is just one of an infinite amount of solutions. All right, now let's write the equation. So if you're going to use y equals mx plus b, then what you want to do for this line, what's the y-intercept? Well, it's 0. Okay, and then what's the slope? Well, you have to go up 1 over 1 to get to another point on that line. So that has a slope of 1. So y equals 1x is that boundary line. Okay, but then now you notice that the shading is dashed. I mean, the line is dashed and the shading is below. So this is going to be y is less than x. So that's your first inequality. All right, the second one has a y-intercept of 3 and a slope of, let's go down 1. And see, it's not quite there. It's a little hard to read. So you have to be clever about counting the slope. We know the y-intercept is 3. The slope, you've got to find a nice non-fractional point. So if we start here, clearly I've got a non-fractional point here, right? So I'm going to count down 3. 1, 2, 3, down 3. So negative 3, 1, 2, 3, and then count right 1, 2, 3. So the slope is negative 3 over 3. Well, that reduces to negative 1. So we have a y-intercept of 3 and a slope of negative 1. Okay, and so that equation is y equals negative 1x plus 3. That's your boundary line, and it's dashed. And it's shaded above, so that would be y is greater than negative 1x plus 3. So that's your system. Now we can test to see if we were right. This point should be true for both of those. So this x is 3 and y is 2. So if I put that in here, 2 is less than 3. That's a true statement. And if I put 3 in for y and 2 in for x, that's negative 1 times 2 is negative 2. So 3 is greater than 1. That's true. So it does work, that this is your solution. It's easy to see graphically, and then we checked it algebraically. So these are just really good problems just to test to see if you understand the concept. All right, pause and try number 8. This is the last one. Which point is in the solution set of the system of inequalities shown on the accompanying graph? Okay, so 0, 0 is right here. No. 3, 3, 1, 2, 3, 1, 2, 3. That's on both lines. But one of the lines is dashed, so that's out because a solution has to be true for both equations. So that one's out. 5, 2, 1, 2, 3, 4, 5, 1, 2. That appears to be in the shaded area. And then 2, 3, 1, 2, 1, 2, 3. That is outside. So this is the only solution. Now there could be more, but in this one we were only finding one of the 4 choices. All right, now let's test our knowledge of writing systems. In this one you can see the slope here is negative 1 because you're going down 1, right 1, and we're going to have to go up a little off the graph. 1, 2, 3, 4, 5, 6 is where it hits the y-axis. And the shading is above, so that's greater than, and it's a solid line greater than or equal to. So put all that together and you get y is greater than or equal to negative 1x plus 6 is our first inequality. Again, this one, if it goes right through the origin, it has a slope of 1, y-intercept 0, slope 1, and it's shaded below, and it's dashed, so that's a less than. So put that together, that's y is less than 1x plus 0, or y is less than x. So that's our system. Now let's test this point. If I put 5 in for x, okay, and 2 in for y, I get 2 is greater than or equal to negative 5 plus 6, or 2 is greater than or equal to 1, and that's true. If I put 2 in for y and 5 in for x here, I get 2 is less than 5, and that is true. So that does work. Now, let's just finish up understanding why 3, 3 did not work. Okay, so 3, 3, that would be 3 is greater than or equal to negative 3 plus 6, which gives you 3 is greater than or equal to 3. Now, that's a true statement, because 3 is equal to 3. However, when I put this here, 3, 3 in here, I get 3 is less than 3. And 3 is not less than itself. And that's why that one doesn't work. Okay, so that's it for systems of inequalities.